Use differentiation to find the coordinates of the stationary point on the curve with equation y is equal to 14x minus 8 minus 3x squared. Use the second derivative to determine the nature of the stationary point. Show by shading on a sketch the region defined by the inequality y is less than or equal to 14x minus 8 minus 3x squared. And then solve the inequality 14x minus 8 minus 3x squared greater than 0 using set notation for your answer. Okay, so we've got y is equal to 14x minus 8 minus 3x squared. If we differentiate that, we're going to get 14, and then nothing from the 8, and then if we bring down the 2 here, we're going to get minus 6x. For stationary points, dy by dx is equal to 0. So we'll put 14 minus 6x is equal to 0. We then solve that, we get 6x is equal to 14. And x is 7 over 3. It said find coordinates, so we need to find the y coordinate. So substitute in 14 times 7 over 3 minus 8 minus 3, 7 over 3 squared. Now, don't get frightened by fractions. Just use the fraction button on your calculator, put this bit in brackets when you square it, and you'll get the answer of 25 over 3. So the coordinates are going to be 7 over 3, comma 25 over 3. Leave them as fractions. Right, for finding the second derivative, we've got the first derivative of 14 minus 6x. If we differentiate again, get nothing from 14 and just get minus 6. So it doesn't matter what x is, the second derivative will always be negative. And according to the second derivative test, that means that 7 over 3, 25 over 3 is a maximum point. Right. Part C, we now need to sketch the curve. So sketching the curve, on the x-axis, 14x minus 8 minus 3x squared will be equal to 0. If we rearrange this to make it easier for ourselves, with 3x squared minus 14x plus 8 is equal to 0. And then we try to factorize it. Now, a lot of students struggle when this is not 1. So this is a little algorithm for you to try and do it for. So you say 3 times 8, so it's 3 times the last number, including the signs, is 24. And the middle number we call the sum, which is minus 14. And then we find two numbers, which when multiplied together, like minus 12 and minus 2, we get 24. And we add the same two numbers, we get minus 14. There is only one possible answer for that. And then we write down 3x squared, and then we split the middle term out into minus 12x minus 2x. And then we put the plus 8 is equal to 0. And then we factorize by what's known as grouping. There's a common factor here of 3x. You take it out and you get x minus 4. Bring down whatever sign is there, which is a minus sign in this case. So we need to be a little bit careful. Group the last two terms together and take out the common factor of 2. And in the bracket we get x minus 4. Remember, a minus times a minus will give back the positive 8. Then x minus 4, well, if you do this process, these two things will always be the same thing. Take out x minus 4, and you're left with 3x minus 2 is equal to 0. So x could be equal to 4, and x is 2 over 3. So it crosses the x-axis at that point. For the y-axis, that's quite easy. If you put 0 in here, you're just going to get minus 8. So here's my sketch. I didn't quite put minus 8 on my sketch in order for it to look okay. Not crucial. Here we can see the 2 points where we've just found for the x-axis. And now, in order to do the shading, you need to take a point. So I'm going to take this point here, which is 2, 0. And remember, we're going to want to find where y is less than or equal to 14x minus 8 minus 3x squared. Write down the expression with a gap in the middle. And then y is 0. And substitute in 2 into the right-hand side. And then you're going to go 0 and we get 8. We'll just go back a bit there. 0 and 8. Which way around does the inequality sign make it right? It's going to be greater than 0, greater than, and then going back up, it's going to be greater than. And that's really what we want. But of course we've got an equal sign here, so we will include points in the region. If you're not going to include points in the region, this curve will have to be dashed. Okay, point is in the region, so we'll shade it, the wanted region in this case, and which is that area there, and we'll make a note that the points on the curve are included. Okay, so make it very clear that we're actually shading the wanted region in this case. Right, in the last part, we're just solving a straightforward quadratic inequality. So we've got 14x minus 8 minus 3x squared is greater than 0. If we factorise it, we get x minus 4, 3x minus 2 is greater than 0. Critical values are going to be x is equal to 2/3 and x is equal to 4. So looking back at the sketch, we'll put those points back on our thing. We want to know where the curve is positive, where it's greater than 0. It's going to be this bit here. So it's going to be the bit between 2/3 and 4, but not including these points this time. And therefore, we're asked to write it as set notation, so it's x such that x is greater than 2/3 intersected with x such that x is less than 4. Okay, so this has been a video to show you how to find a stationary point, determine its nature, and solve shading inequalities and solving inequalities. In the notes of the video, I'll put the links to my website where you'll find thousands of videos to help you with A-level maths, and maybe you could consider subscribing to my channel. Thank you very much for watching.